Control expressions are used in order to control which micro operation should be performed or whether the register should keep its current value. The control expressions for an operation appear on the left side of the operation, as you can see here. Here we have two examples, and then it is separated from the rest of the operation by a colon, and that's what you could see over here. So colons here are used in order to separate the control expressions from the operation. As I mentioned, the control expressions determine which logical or arithmetic operation should be performed based on a logical condition. Therefore, what we receive as the result of evaluating this control expression would be in the form of a 0 or a 1. So if we end up with a 1, it means that the operation in front of it should be performed. If we receive 0, it means that the operation should not be implemented. That's again written here. Logic 1 means that the operation should happen, and logic 0 means that the operation is not going to be evaluated or performed. In the example we have here, we have the control expression not x and k1. When it's true, meaning that when it gives us 1 as the result of ANDing of not x and k1, then the content of R1 will be added to R2. These are two registers, and the result will be stored in R1. On the other hand, if we have x and k1 equal to 1, meaning that both of them are equal to 1, then R1 will be added to the complement of R2 plus 1, and this is, as you should know, is giving us the subtraction. So what we have here is R1 minus R2. This operation will be performed and the result will be stored again in R1. You can see that in order to perform any of these operations, we need to have K1 equal to 1. If K1 is equal to 0, then nothing will happen and the content of R1 will not change. That's again written here as well. When x is equal to 0, then not x obviously is equal to 1, and if k1 is also equal to 1, then not x and k1 will be equal to 1, and therefore the addition of R1 and R2 will be performed. On the other hand, if x is equal to 1 then and k1 is equal to 1, then x and k1 will be equal to 1, and in that case the subtraction will happen. You can see over here how the whole configuration is set up here in this block diagram system. At the center we have the adder subtractor. You should remember from past that for the adder subtractor we will have two main inputs, which are the operands A and B, you could think of, and then we have a select input, which is x in this case. Again, you should remember that with select input, which is x equal to 0, we will have A plus B, and with x equal to 1, we will have the subtraction of A minus B. You can see that one input here is R2, so the data comes from R2 register. The other input comes from R1, as we have the connection in this way. So the second input over here is R1, over here we have R2. Depending on the value of the x, the addition or subtraction will be performed and the result will be available here. But that result will be written into R1 whenever K1 is equal to 1, because then it will enable the register to be loaded with new data. K1 is connected to the load input of the R1. So while K1 is equal to 1, then the register will be able to be loaded. What to load into it, it would depend on the value of X, whether the result of the addition or whether the result of the subtraction. And while K1 is equal to 0, if K1 is equal to 0, then R1 will not be loaded. It will store its old value, so nothing will change in it. You can also see that as the result of the using adder subtractor, we also have the carryout Cn and the carryout of the previous stage Cn minus 1, which could be used in order to determine the overflow and the carry on. But even for those, since we need only a single bit, a single flip-flop would be used for V and for C. At the same time, the K1 input that we have as one of the control inputs is connected to enable input of those flip-flops. So only when K1 is equal to 1, the value for the C output and for the V output flip-flops will be in it loaded and updated. Otherwise, they will keep the last value that they